Hi, I'm Narendra Kumar, and in this video, we are going to understand in detail about Unity Catalog. We will start by understanding what exactly is Unity Catalog, and then we will understand all its core features in detail. Many people they just think that it is metadata management tool and replacement of Hive Metastore, but it is so much more than that. We will understand it how it works as a catalog, how do we control the access in Unity Catalog, how it provides automated lineage, what all system tables are there, and how and what purpose we shall use those, how we can share the data with external users, how we can connect external sources in Unity Catalog, and how we can monitor data quality automatically as part of the Unity Catalog. And all these features, we will understand them via a demo. So let's get started. We will first understand what exactly is Unity Catalog. So this is the official definition. It is a centralized data catalog that provides access control, auditing, lineage, data quality monitoring, and data discovery capabilities across Databricks workspaces. So at the core, it is a data catalog, data and AI catalog, which provide all these features, and it is centralized and works across Databricks workspaces. So what exactly it means is like that we can see here in this diagram. Before Unity Catalog was there, so each of the Databricks workspace, let's say there is a dev workspace, prod workspace, and other as well for a given company. For each workspace, we had to manage the users separately. What users are there, what are user groups, which access are provided. So all those we had to maintain separately for each and every workspace. Similarly, what all tables and their metadata was there, that was also tied to a single workspace. So that was the default Hive metastore in most of the cases. So accessing that data in another workspace was also a problem. Similarly, compute wise also it was and it already is. Compute has to be part of the workspace only. That is how it works. So in 2021, when the initial release was there for Unity Catalog, so that time they solved this core problem about user management and metastore or metadata management. So here, as part of the metadata management, they replaced the Hive Metastore and the user management. Both of these things they brought up in a central unit instead of maintaining these two things separately for each and every workspace. They built this central application which can work, or it was a central control for all the workspaces. After that, at workspace level, we don't need to maintain all these things. So that is where Unity Catalog it got started. Now let's understand its first feature, uh, about the uh, metadata management. So it is a data and AI catalog, as the definition suggests. So uh, it has a unified catalog for all the structured, unstructured business metrics and AI models. Everything can be registered as a metadata in Unity Catalog. So here are all the objects that we can create in Unity Catalog. So at the top level, we have a metastore, which we create only one metastore per region. And within the metastore, we have the core component, it is catalog. And apart from catalog, it has other standard components as well, which are like more from the admin perspective. And then within catalog, we have something called a schema, which is very similar to database in other database systems. And within schema, we have table level objects. Apart from table, we can also have a view, volume, model, uh, functions. So any specific object that comes under any schema. So that is how things are organized in a metastore. This Unity Catalog Metastore, and it follows three level namespace. So let's say if we want to access any table, we follow three level namespace. First the catalog name, then schema name, then table name. So let's understand this more via the demo first. So here is my Databricks workspace. and here I have opened one of the table. So on the left side, if we see, so here like this DB training and system, these two are catalog. Within the catalog, we have all these schemas. Within this training schema, we have a table. So that is how objects are organized here. And if we want to look at the top level element like metastore, how exactly it is created and mapped to all the workspaces, so that can be seen from the settings icon. This is the metastore where this current all these catalogs are linked to. And for this demo, I'm using the paid version of Databricks because this Unity catalog management, many features are not there in free edition. So I wanted to explain those so that we can understand how it exactly it works, and also how exactly we can create these meta stores and manage things. So that is where we go here in this drop down, and here we get this option manage account. This option, it is always not always, it is available only for the account admin level people. So if I click it, it will take me to a totally different UI which is accessible only for admins. And this is where we maintain a lot of things related to Unity catalog. So here, if I go to a catalog, this is where the main catalog, the top level object I have created. We can create a new one from here, but in one region, let's say East US, we can create only one. And then that catalog we may map to a workspace. Currently, I have only one workspace, and in that workspace, I have mapped that metastore that I created in this catalog UI. If we have multiple workspaces, there also we can map the same metastore. So that is how it works. So this is the one workspace that I had opened, this DB training, and this is where that same meta store it is linked. So that is how things are linked. We have a single meta store. We can have multiple workspaces, and then in terms of catalog, we can have multiple these schemas within. Sorry, multiple catalog. Within catalog, we have multiple schema, and then we have the table views all those objects. So that is how things are structured in terms of a catalog for Unity catalog. Moving on to the next feature that they solved was the fine grained access control. So there are a lot of things how access is controlled within Unity catalog, but high level it can be categorized into four different things. One is workspace level restriction, where it all started. Like instead of maintaining the things at workspace level, all the things can be set up at Unity catalog, and for that we need to set up workspace level accesses in the portal that I showed. And then there is privilege and ownership level. So here we can control the access on tables, catalogs, schemas, and other objects based on the users or user groups. And then there is attribute based policies. So these are like tag and attribute related access controls. So for example, for different tables or different clusters, we provide some tags as key value pair, and depending on those attributes, we can control the access. And the last one, it is like table level filtering and masking. So for each table also, we can define row filters, column masks, dynamic views and all, where we can control what exactly data shall be shown to a particular group of users. And all these different layers, they work together to control the access in the most granular way. So let's get a quick glance. How does it work? So now I'm back in my uh, workspace, and here in the I'm currently in the account console. If we go to user management, this is where we manage different users, different groups, or different service principals. And these same users and groups we can provide access in our workspaces. So that is how things work. And which user can access which workspace, that also we can control access from this workspace permissions here. And if we go inside the workspace, I'm in the DB training workspace. So for each and every object, let's say here it is a table, then tables also has a permission section here. So we can control what kind of access we want to provide. It is available at the schema level, we can control access. At the catalog level, we can control access. If there is a dashboard, we can control access. AI model, whatever object we create within a workspace, everywhere we can use those same users, same groups and control the access. That is how all these things work together. So these were the two core feature, like a central user management and central metadata management, where Unity Catalog started. But with time, it has included so many new and useful features. So let's understand them as well. So the next feature we are going to discuss, it is the automated lineage. So whatever operations are performed within Databricks, for each and every operation, it keeps track of the lineage across different queries that are run. And lineage, it is supported for all the programming languages, and it is captured not only at the table level but down to the column level as well, which we will see in the demo. And lineage, apart from the table and column relationships, it also includes notebooks, jobs, dashboards, everything it captures. And if we want to add our own custom lineage, that also we can do within Unity Catalog. And the lineage related information, it is retained for 1 year, and after that, it is cleaned up. This is a sample lineage, but let's check out via a demo how exactly it works. So now I'm back in my Databricks workspace and I have opened one table. If I go to this lineage section, so by default, it will show some objects which are related to this table, downstream or upstream. But to get a better visibility, we click on this option, see lineage graph. Once we click it, it will show a visual representation that whatever query I had used to create or populate data in this table, so the data was used from these two tables. So this is how table wise relationship it is showing. If I click on any of the column, it will show that that country column, it came from this country column from this table. That is how column level information also we can fetch. Let's say this column, it came from here. And if I click, let's say this table here, so apart from column, it will also show a lot of other information as well. Let's say here we can see that this notebook was used, this dashboard is using this table, and these two tables were used to populate this table. This is the job that populated it. So all that information we get automatically populated within Databricks. So this is how the lineage works. Now the next feature, it is Lakehouse Federation. So in Unity Catalog, we can not only control the data within Databricks or Unity Catalog, but we can also manage external data as well. So let's say if we have data from any of these sources, be it Teradata, MySQL, Snowflakes, Azure Synapse, or any of these, those external data sets or databases, we can connect to Databricks and we can use that data without copying that data. So directly we can access the data, we can run queries on that just by making a connection. So that feature, it is called as Lakehouse Federation. So for that we can uh, access this data without any copy. So let's see how exactly we can make this connection. So now I'm in my Databricks workspace, and in the catalog, if we go to Catalog Explorer, in this setting section here, we see this connections option. And if we go here, this is where we can create a new connection. We can give it any name. We can select the type, which type of database we want to connect. So all these are supported. If I select any one of them, then if I select any authentication type, then it will uh, ask for other further detail where we can check what all things are required to access, and then a connection will be created. So this is how easily, just using this UI, we can connect to external data warehouse and then access that data without copying. Next, we are going to discuss about the data quality monitoring. So even though data quality monitoring, it is itself, it is a very big topic, but Databricks, I would say this is a new feature, and Databricks, it is getting started on doing stuff about data quality. So currently, when it comes to quality monitoring, the automated features within Unity Catalog, so we have these two features. One is anomaly detection and one is data profiling. In anomaly detection, we can check out two things. One is freshness, like how recently a table has been updated and whether it is updating based on the regular schedule or it is delayed. Second is completeness. So this one it checks like a number of rows that are expected. Are we getting as per the expectation or there is a sudden increase or decrease in the last 24 hours? So that check it does. And then in terms of data profiling, it provides a summary of the statistical data about the table, like how many unique records are there, what are their min max values, and like that. There are so many other statistics it can do, and that can be used by the GenAI applications. And apart from table level, we can also track the performance of GenAI apps, machine learning models that we create. Now let's check out as a demo how exactly we can use those automated features. So currently I have opened a table and this is where we get the option like quality. So if we go to quality, this is where we can enable it. Uh, to enable it, we need to set up some of the configurations and after that automatically it will start monitoring the quality of the data. Now the next feature we are going to discuss is delta sharing, which is again very famous topic and it has become very powerful over the period of time. So as the name itself suggests, it is about sharing the data. So we can share live data from our tables without any replication to external users. And it is built on open standard formats and protocols. So it does not have any vendor lock-in. Even this delta sharing feature or even the Unity catalog itself, it is available as a open source tool as well. So these can be used outside Databricks as well. And when we are sharing the data, we get the inbuilt governance of Unity catalog, and we get a marketplace also where we can share our data and sell it as a product, where other companies, if they want the data, they pay some amount and then they can use our data, our AI models, or whatever we want to share. So how it works is like, let's say if we have a table or any object, we when we configure delta sharing on that particular table, so a small delta sharing server is created. It follows a very standard protocol. Based on that protocol, all these different users, they can use the data, be it different analytics or BI related users, or any tools that can use this protocol. Wherever it is supported, they can do it, or it can be used on any of the cloud platform. So the data, it becomes very useful to external users whatever they are using. So now let's see how exactly we can use it. So here we get this share option. I have currently a table, and in the share we get this option, share via delta sharing. If I click on this, we need to create a share, like it's a one time element, and then inside that share we can share our table. Then whatever recipients that are specified, so with those recipient the data will be shared automatically. So that is how it works. And this is one of the feature, and similarly the marketplace that I was talking about, that is available here. If we go to this marketplace, here we can see whatever open source data sets that are provided. So we can simply click it and get this data or whatever models, whatever details are being provided, everything we can access in our environment. Some of these are free, some of these are paid. And similarly, we can also put our data sets or our models in the marketplace and sell it. So that is how easy it is to like share and earn from our data and models. Now the last feature, but very important one, it is the system tables. So out of the box, Databricks, it provides some tables which provide very deep visibility in terms of the platform operation, governance, lineage, usage, billing, all the things. So these are some of the examples of the system tables. Let's say we have assistant events. So whatever operation we do with the Databricks assistant, it tracks that. Whatever accesses are other accesses are being done within workspace. So this table tracks that. Table lineage is available here. Whatever cluster or job is running, so for that one, the usage and pricing is tracked. Similarly, other compute related information are tracked in these table. Lake flow level and job and task level information is captured here. Whatever SQL query we are running, that is also tracked here. So each and everything, it is tracked in terms of these system tables, which provide lot of visibility, where we can just check out things using SQL query or create even dashboards to monitor the things properly. So to show the system tables, I am back in my Databricks workspace. And in this catalog, this is where we see the system catalog. And for this catalog, by default, the normal developers, they will not be having access. So if you don't have access, you can ask your admin to provide the access. And within this system, we see all these categories. So let's say compute related information, everything related to the cluster, nodes, warehouse, it is stored here. Whatever queries are being run, so that query history, it is stored here. Whatever jobs we are running within Databricks, so for each and every job, even task level information, it is captured. What task it was successful, what parameters was passed, whether it was success or not, what time it run, each and everything, it is tracked in terms of this table. And with time, like knowing that this information is stored, it is really really helpful to keep track of the things. So that covers all the features of Unity Catalog, and that is what I wanted to explain in this video. If you still have any doubts, please put a comment. And if you like this content, please put a like and comment. And that's all for now. Thank you. Bye bye. Happy learning.